This is shining green. We hope the future of energy may be somewhat green. Let me talk a little bit about energy. Does someone have a clue, an idea why energy and nanoscience could be related? Anyone?
Membranes?
Yeah, membranes are certainly an important aspect. You can think about many applications. For example, getting rid of salt in seawater is important. Water production is always related to energy, so there's an important link. I am in the position that I lack having, let's say, a 5-year-old boy or a girl. What does that mean? Well, it has advantages, of course. It can work even longer, but I miss out all the wonderful toys, right? And that's really frustrating. However, so if imagine you go into a shop and say, oh, well, you have all these wonderful toys, I look for a toy, and then the salesperson comes to you and asks, well, for what age? And then you say, 44. And then they send you in the wrong direction, right? That's not what I want. What I want is something remote controlled and something robot, right? Something awesome. What the kids have, super soakers, this kind of stuff. Now, I have an excuse when I say I'm a scientist, because then I can say, well, we made it possible that these things are there. And I recently, of course, not for this show, for me, bought, guess what? A remote-controlled helicopter for 20 bucks, which can fly indoors.
Does it fire a missile? The missile is 40 bucks. My salary doesn't allow for that.
Yeah.
Okay, I bring it down to more or less safe landing, maybe.
Cool.
More or less. Okay, less.
Now, let me come back to the question, of course, how is that related to energy? Well, we almost said it. It requires the two important components. We need the modern lithium batteries, and an aspect of this powerful and high energy density of these batteries became possible because of nanotechnology. But most importantly, in this case, you really need to have this lightweight and strong electric motors, and they require very strong permanent magnets, and that wasn't possible too long ago. That brings me to another point which is really important for me as a physicist, and it's not so much about science, nanotechnology, it's really about nanoscience, and it's about the question, why are physicists in particular interested in nanoscience? And well, let me show the answer in one typical, beautiful figure created by these guys here from IBM in this group. So again, of course I have a reference, but it's cut off. So that's the question, and I immediately answer it when you see this. That's basically the final product of the manipulation, bringing atom by atom in a so-called quantum coral, here a ring structure. And what has been done here is 58, I think, 48, I'm always accelerating, 48 iron atoms into a ring, again on the beloved kappa 111 surface. Now, if you are not yet impressed, give me a second. I mean, first of all, to do that, to bring atoms in such a completely organized structure, atom by atom, is breathtaking. I was shocked, literally shocked when I saw this the first time. It's actually quite a while ago. And what you also see that may be even more shocking is you see these ripples here. And these ripples are actually a fingerprint of the standing electron waves which form in this quantum coral when you do manipulations with your tip of your device. In this case, it's a modified scanning tunneling microscope. And That is one of the reasons why physicists do nanoscience. Let me be a little bit more specific. And here is a summary why we would do that. So what we see here is the quantum nature, the fundamental laws of physics in action. And not too long ago, people would have said it's absolutely impossible to see these things, which are solutions of what theorists think about in quantum. What we try to do here is to have a sneak peek, so to say, in God's cards, if you want to say it in a somewhat dramatic manner. So we want to, I think Einstein has said something similar, we really want to see how the old guy is doing his job. Now, why do I show you that? For two reasons. Because it gives me a bridge to this experiment, but also because to a large extent, that is today what nanoscience and nanotechnology is all about. That's what we basically do. Because what we can do is when we make objects smaller and smaller, we, in a sense, play with the length of this box where the electrons can propagate in. And that means that the solutions, these standing waves here, can be tailored. So the wavelength can be tailored. In other words, by tailoring this wavelength, we tailor the energy levels in our materials in a very similar way as you know that there are energy levels in an atom. A classical analogy to this kind of standing waves. And you can see when you change the length here, for example, the region where a guitar string can vibrate, if you change this length, then you change the wavelength of these standing waves, or eigenmodes as we call them. And that is, in a sense, the essence of, or one important aspect of nanotechnology on the nanoparticle side. And that brings me to my final experiment, which I want to show you. And Steve, I need your help here.